Good morning, guys. Today we're going to be doing section 6.4. We're going to be simplifying exponential statements. So do take notes, please. You should be keeping your notes up from these videos, okay? So the first part of your worksheet, like the actual first 4 questions, I think, you're just changing forms. So it's just review from the previous worksheet. You're going to change from radical form to exponential and vice versa. And then there's a middle section here where you're going to be reviewing, simplifying a radical like this one. So remember, if I have a third root, I'm going to be looking for copies of 3 in order to bring 1 out. So I would just break down 16. 16 is 4 times 4. And then each of those are, I'm not sure why we're zooming here. Okay, so each of those are 2 times 2. I would go ahead and circle all the primes. I need 3 copies again, so I would take 1, 2 out for those 3, which would multiply by the 1 out front, so I get a 4. This 2 would have to stay under the cube root. And then with my n to the 4th, that means n times itself 4 times. So for these 3 here, I can bring 1 out. That one would have to stay inside. So 4n on the outside, 2n on the inside. So again, this section is just review. There's a kind of a middle section where you're just simplifying radicals. Okay, so the part that will be new today, let's go ahead and take a look at that. It will look like this. So I have 8v to the 9th, and 8v to the 9th is raised to the 4/3 power. So notice here I'm asked to simplify. I'm not just changing forms here, although I will change forms in order to help me along. But I actually need to simplify this down now as much as possible. So the first thing I'm going to do, my first step, is to change to radical form. So in order to do that, this is the same thing that we learned yesterday. I'm just going to put the 8v to the 9th underneath my radical. I know that the 4 is my power, so that will go up here. And the 3 is my root, so that will go down here in this little v. Now, I actually want to evaluate the 3rd root here, and I also want to evaluate the 4th power. It doesn't really matter which one I do first. The order won't matter. I can either take the cube root first and then raise it to the 4th power, or I can raise it to the 4th power and then I can simplify the root. You'll get the same answer either way. However, if I do the 4th power first, that's going to make this 8 into a pretty huge number, and then I'm going to have to break that down to get the 3rd root. So it's probably going to be much easier to take the root first, because that will make these become smaller numbers, and then I can raise them to the 4th power. So although you can do it either way, I would definitely evaluate the root first. So our second step is to evaluate the root. Now, okay, so you're going to evaluate the root. You're going to completely ignore this 4 at first. We're just going to do this part. The 4 is still there, but we're going to just ignore it while we simplify this piece. So I'm going to actually take the cube root of 8v to the 9th. So I'm breaking down 8. 8 is 2 times 4, and 4 is 2 times 2. And again, this is a cube root. So because there are 3 2's under a cube root, that means I can bring a 2 outside the cube root. V to the 9th, that's V 9 times, right? So I have 3 groups of 3. So 1, 2, 3 V's can come out. V times V times V is V to the 3rd. Now, notice that everything came out here, and there's nothing left inside the radical. So the radical part just goes away, and I have 2V to the 3rd outside And now I need to remember that everything was raised to the fourth power. So I'm going to raise 2 to the fourth power, and I'm going to raise v to the third to the fourth power. Remember, if I have a power raised to a power, I multiply the power, so this would be v to the 12th. And then I can simply multiply out 2 to the 4th. 2 to the 4th is equal to 16. So this would equal 16 v to the 12th power. Okay? So let's go ahead and try another one. We'll get up our next example here. One's kind of similar, so I think I'm going to skip ahead. Let's try this one. So we have 64v squared raised to the 3/2 power. On my previous slide, I forgot to write down step 3, and step 3 was to evaluate the power, right? Once you've simplified or evaluated the root, then you evaluate the power. So that's the third step. All right, so let's go ahead and do the first step, which would be put this in radical form. So the 64v squared would go underneath, that's the base. The 3 is our power, so it's going to go out here. The 2 is our root, so that will go under here. Again, I'm just evaluating the root first, so I'm going to ignore the third power for now. A square root means if I have 2 numbers the same underneath, I can bring one out. 64 is actually a perfect square, right? That's 8 times 8. And I could continue here on 8 and 8 and break them down further to 2 and 4 and then continue there. But because 8 times 8 is 64 and there are 2 8s, I can actually just go ahead and pull an 8 out there. But if you were to go all the way down to primes, you would still get the same answer. You would get 3 sets of 2 that you could pull out, and then 2 times 2 times 2 is 8. So either way works. V squared, if I take the square root of that, v times v, that means there's 2 v's underneath the square root, which means 1 can come out. So 8v is the square root of 64v squared, and there's nothing left underneath, so the square root goes away, and now I'm raising to the third power. So 8 to the third times v to the third. And then I can go ahead and evaluate 8 to the third. So 8 times 8 is 64, and 64 times 8 is 512. Whoops, it's disappeared here. So it would just be 512. That is not a 12. Oh man, my marker is struggling. So 512 times v to the third. So we're just going to do a few more examples of the same type of thing here. And then we can give some of these a try. So here we have 8n to the 9th raised to the 2/3 power. So again, my first step is just to put this in radical form. I've got 8n to the 9th underneath. My root is 3. My power is 2. I'm going to do the root first. Ignore the 2 for now. So I will break down 8. That's 2 times 4. 4 is 2 times 2. So I've got 3 2's under a cube root, which means I can pull out a 2. N to the 9th, that's n to the third 3 times, so I can bring out n 3 times. So n times n times n is coming out. And nothing will be left underneath. So then I'm going to square this. So 2 squared times n to the 6th, or 4n to the 6th. All right, let's try just like maybe 1 or 2 more, and then that'll be it for today. Here we have n to the 9th raised to the 4/3. So again, n to the 9th goes underneath. Our root is 3, our power is 4. We'll evaluate this first. So if I have 9 n's underneath, that means n times n times n can come out, right? Because there's 3 groups of 3 underneath. Nothing would be left inside. Raise that to the 4th power. And that equals n to the 12th. Wow, this is just being difficult. Okay, so let's just do one final example, and then you guys can go ahead and just try these on your homework. Let's see what we've got here. Let's do this one. So here I'm going to change to radical form. So I've got 81 into the 4th. Goodness. This is a square root. It would be to the 1st power. Because it's to the 1st power, I don't need to do that 3rd step, right? I won't need to raise it to a power. All I need to do is take the square root of 81 into the 4th. 81 is a perfect square, so the square root of 81 is 9. If I have 4 n's underneath, n times n times n times n, that means I have 2 groups of 2, one here and one here. So I can bring out an n, and then I can bring out another n, and n times n is n squared. Again, since that was just to the 1st power, I'm just done there, so 9n squared. So go ahead and give these a try, guys. Please don't hesitate to email me if you have any questions about any of this, and have a great day.